Hi students, just making this video to help you with understanding pure substances and mixtures, and hope you'll take your notes. You notice that this is one of the assignments is to take notes on what I am discussing here. All right. So everything in the world, you guys, can be divided into all matter, which is not energy, divided into either pure substance or a mixture. Okay, and pure substances is where we'll start. We're going to talk about pure substances. There's an element, which, as you know from your middle school science, there's 100 and something elements in the world, and the way you can tell one from another is the number of protons in the middle. Okay, they are a pure substance. An element is a pure substance, can't be broken down into anything else, and maintain its physical characteristics. All right, the other thing is that's a pure substance is compounds. And we discussed this last week. Compounds are when you have two different particles and they chemically bind together. All right. Why is this considered a pure substance? Well, the only thing we have here are, and this is water molecules, I believe, 2 reds, 2 hydrogen, 1 oxygen. So because they're all water molecules, they are compounds, but they are pure substances as well, because all there is water molecules. All right. We're done with pure substances. Now we're going to talk about mixtures, which we looked at last week. We know that a mixture is something that can be separated. Okay, salt water, that's an example. Salt and sand, that can be separated. All right, there's 2 kinds of mixtures. Homogeneous, which means homo means one, and heterogeneous means more than one. So homogeneous mixtures are evenly spread throughout, and you can't see necessarily what they are. Heterogeneous mixtures, they have distinct visible parts, and they're also not separated evenly. Okay, not separated out evenly. All right, remember that these are all the elements in the periodic table. The periodic table of elements has all the elements we know. Okay, let's review. So pure substances are either elements or compounds. What's some example of elements? Oh, nitrogen, oxygen, gold, silver, iron. All of those are elements. Okay. They're the smallest particle of an element that has the properties of that element. Excuse me. Then there's compounds, and that's when 2 different substances are joined chemically. H2O is a compound. CO2 is a compound. All right, next, you guys, is mixtures. Again, we're kind of reviewing what I said. Heterogeneous mixtures, all the components are visible, and they don't mix together, and they're not evenly distributed. And homogeneous mixtures, you guys, the components cannot be distinguished from each other. It appears as one substance. The particles distributed evenly throughout. Example, the air we breathe, right? It has nitrogen and all types of gases in it. Okay, remember, heterogeneous, all components of the mixture are visible, particles not distributed evenly. Homogeneous, components cannot be distinguished from one another, appear as one substance. Particles are distributed evenly. If you've ever made iced tea, forget about the ice, but think about the tea and you put some sugar in it, and you can't really see it because it's distributed throughout equally, right? That would make it a homogeneous mixture. These 2, heterogeneous, soup and trail mix. You never know what you're going to get when you grab a handful. All right, oil and water is a heterogeneous mixture. This is brass. It's 2 types of metals that are mixed together. That is a homogeneous mixture. Okay, so think about each one of these for a moment. Think if it's heterogeneous or homogeneous. I don't see anything different here, so I would call it homogeneous. This, on the other hand, it has some olives over here, but not over here. So it's heterogeneous. Homogeneous is not what this is. This is heterogeneous. You guys can see the olives, you can see the mushrooms, you can see the pepperoni. Okay, that is heterogeneous. This, you can't see the different things, so I would say that's homogeneous. Chicken soup, heterogeneous. You can see the carrots, you can see the chicken, you can see the noodles. Frappuccino, yum yum in the morning. This is homogeneous because you can't see the different parts, right? And this trail mix, definitely heterogeneous. This, homogeneous. Okay, let's learn a little bit more. Okay, homogeneous mixtures are also called solutions. Their separate particles are not visible because one dissolves into the other. In salt water, salt is the solute. It gets dissolved, and water is the solvent. It dissolves the other substance. All right, why do two substances dissolve and others do not? We know that sugar will be dissolved by water, but what do we know about sugar and ethanol? Doesn't dissolve, right? Does not dissolve. So if the attractive forces between the water and the solute are strong, then what's holding the solute together, the solute will break up down and dissolve in the water. That's just in the way of an explanation. Okay, solubility, the ability of a solvent to dissolve a solute. It's the maximum amount of solute that can be dissolved in a given amount of solvent at a specific temperature. Usually expressed as a number of grams of solute per 100 grams of solvent. Okay, every chemical substance which dissolves in water has a fixed solubility. If it does not dissolve, then the solubility is zero. Like solubility of sugar and ethanol, zero. Many of these solubilities have been measured, in their charts that'll tell you about the solubility. Okay, let's slow down. This is the last thing I want you to get. Solutions. If you have the maximum amount of solute dissolved in a solvent, then that solution is saturated. If you have less than the maximum amount of solute dissolved in the solvent, it's unsaturated. Finally, if you heat the water up real high and you get to put more water in it, more solvent, then it's supersaturated. And finally, if it has just a little bit of solute and a lot of the solvent, we call that dilute. All right.